Hello, welcome to Chromatography application in food industry. These are our team member, Hazrin Eliya, Irwanie Aina and Ain.
Assalamualaikum, my name is Ain Hazrin Eliya and my ID number is 20224956. Now I'm going to talk about the introduction of chromatography. So what is chromatography? Chromatography is a technique in which components of a mixture that are separated based on differences in the rates at which they are carried through a fixed or stationary phase by gases or liquid mobile phase. Chromatography has also numerous applications in biological and chemical fields. It is widely used in biochemical research for the separation and identification of chemical compounds of biological origin. For example, in petroleum industry, chromatography is used to analyze complex mixture of hydrocarbons.
Hi, my name is Nurul Ain Atikah Bentinar Hisham, student ID 2022897502, and I'm gonna talk about the theory of chromatography. So, do you know that chromatography helps detect drugs and additives in foods? Such in essence, chromatography is a technique used to spread the component of a mixture. The process begins by dissolving the mixture in a substance called the mobile phase, which then moves through another substance known as the stationary phase. Even though additives are safe now, the FDA still regulates them strictly. This technique ensures accurate nutrition labeling and verifies the safety of the foods and beverage that we can consume. Now, let's move to the application of chromatography, the most important one in the food industry, where it is used to identify the various ingredients in food products. Companies rely on chromatography to analyze the nutritional content of their product, including proteins, vitamins, drugs, and other components. This technique enables businesses to accurately determine the nutritional value of their item, ensuring compliance with health standards and providing consumers with precise information. Furthermore, chromatography helps in quality control by detecting contaminants and verifying the purity of ingredients used in food production.
Then, determine drugs. As mentioned previously, we can determine the presence of drug in food using chromatography. Now, let's dive deeper into the specifics of how drugs in food are identified using this technique. It is crucial to examine foods for additives, even if these additives are generally safer and less harmful than contaminated foods. Food manufacturers use additives for various purposes, including preservation, coloring, and enhancing flavor. Despite their improved safety over the years, the FDA still rigorously regulates food additives. By employing chromatography to identify these additives, we can ensure the accuracy of nutrition labeling. This helps us understand exactly what's in the food and beverage we purchase and determine whether they are safe for our consumption and that of our families. Chromatography not only detects the presence of additives, but also quantifies them, providing detailed information about their concentrations and potential impact on health. Next, we move to types of chromatography in determination of drugs. Within chromatography exist different techniques and strategies for food testing. The two main types of chromatography in food testing are gas and liquid. So, the most suitable type for determining drugs in food is by using TLC.
Hi, my name is Aina Batrisha binti Muhammad Zamri and I will continue about the methodology. The methodology that we choose is TLC chromatography. TLC chromatography or thin layer chromatography is a technique of separation of mixture aqueous on a thin layer of absorbent silica or alumina which is attached or coated to an inner support, usually glass plate. It also is a technique that is frequently used during food evaluation, and quality control for food industry. It is used for separation organic compound, check purity of product, and the type is adsorption chromes, solid to liquid. There are two things need to be considered before doing this methodology. First is stationary paste, that is thin layer plate or strip coat with a silica alumina. Next is mobile paste. Organic solvent or inorganic solvent is a solvent which travels up the plate carrying the substance.
Hey, it's me again, and I'm gonna teach you the methodology of chromatography experiment. Step 1. A line parallel to the short dimension width must be drawn 3 cm from the bottom edge of chromatographic paper with a pencil. Step 2. For small x, it was marked along the line equally distant or about 3 cm from each other. Step 3. The bottom of each x were labeled with red, blue, green, and yellow. Step 4. About 50 ml of the preparable developing solvent, which is 2 grams of NaCl in 100 ml water, was poured into a clean dry 600 ml beaker. Step 5. The chromatographic paper was laid on the table. A tiny spot of each foot dye was placed on each X mark. Using a microcapillary, it was repeated when necessary. Step 6. The paper was hanged using clamp and retard stand or either a glass rod or pencil. The paper is to be slowly immersed in the beaker containing the developing solvent. Care should be taken to ensure that the paper does not touch the wall of the beaker and that the level of solvent is below the line drawn, below the spot. Step 7. The solvent is allowed to rise until about halfway, middle length. The paper is then taken out from the beaker and the solvent front is marked. And lastly, the paper is allowed to dry for 5 to 10 minutes. Then the line for the marked solvent front is drawn, and you will cut the result like this. Ta-da! That's all from me. Thank you.
Assalamualaikum and hi everyone. I am Irwanie Eliya Ismail and my metric number is 2022817892. Now, I'm going to explain the example and the results. Firstly, we have the coffee beans. Technique used is HPLC or high permanence liquid chromatography. By using this technique, we can separating and identifying the different components found in coffee beans, including acids, oils, and caffeine. HPLC can produce a comprehensive profile of the chemical makeup of the bean. Next, we have honey. The method used is TLC or thin layer chromatography. TLC can distinguish between the various sugars and additives in honey, guaranteeing its authenticity and purity. It is a rapid and efficient way to find adulteration. Third, we have cheese. Capillary electrophoresis or CE is the method used. The proteins and peptides in cheese may be separated and analyzed by CE, which gives information about the cheese flavor, texture, and ripening process. This promotes consistency in the final product and standardizes production. Lastly, we have olive oil. The technique we use is LCMS, or liquid chromatography mass spectrometry. Olive oil's phenolic components, which are a sign of its quality, purity, and health advantages, can be detected and measured by LCMS. Using this technique guarantees the product legitimacy.
In conclusion, chromatography is very important in food industry. It is because chromatography application range from ensuring food safety and quality control to aiding in the development of new products. It is also has been proven to be an invaluable tool in food industry, offering unparalleled capabilities in the analysis, separation, and purification of complex mixtures. Furthermore, chromatography is instrumental in identifying and quantifying flavors, colors, preservatives, and other additives, providing manufacturers with precise information to maintain product consistency and consumer satisfaction. Last but not least, not only it enhances safety and quality of food product, but also drives advancement in food technology and research, contributing to development of healthier and more sustainable food options in the global market. That's all, thank you.
These are our references that we use in this video. Thank you for watching. Any question, don't hesitate to ask.